So let's prove the laws of reflection and refraction using Huygens principle. Okay, so first we'll prove the laws of reflection. Now suppose this was a boundary and this is a silver surface, and you have a plane wavefront which is traveling and which is meeting this surface. Let this wavefront, let us call this point as A, let this point as B. This is the wavefront. So if this is the wavefront, the waves travel perpendicular to it. So this is how the waves travel. So the wave travels perpendicular to it. So this is all perpendicular to it. So these are the rays. Okay, AB is the wavefront. AB is the incident wavefront. If it is the incident wavefront, the angle which the incident wavefront makes with the plane is what is called as the angle of incidence. So this is I, the angle of incidence. Now understand that as soon as this hits here, this wave will get reflected, and this wavefront which is traveling which is traveling this way hits here, and it will move, it will get reflected and it will move somehow. So suppose the reflected wavefront is given by this. That means this A has reached here, so I'll call this as A dashed, and this B has reached here, I'll call this as B dashed. So AB is the incident wavefront, A dashed B dashed is the reflected wavefront. And the angle which the reflected wavefront makes with the plane is what is called as R, the angle of reflection. Okay, then I can say that look, the time taken by the wave to reach from A to A dashed is equal to time taken by the wave to go from B to B dashed. Why? Because it's the same medium and velocity remains the same. So this is Vt, this is also Vt. Now consider two triangles. Here I am taking triangle B, B dashed, A dashed. Here I am taking triangle A, B, A dashed. Okay, in triangle B, B dashed, A dashed, B, B dashed, B, B dashed is equal to Vt, which is equal to AB, no, I'm sorry, which is equal to A, A dashed, which is also equal to Vt. So this is Vt and this is also equal to Vt. Now this angle here is 90 degrees. The angle between the wave and the plane, the wave front, is 90 degrees. Similarly, this is the reflected wave front. So I am so sorry, this is the reflected wave front and this is the perpendicular, so this will be the reflected wave. If this is the reflected wave, then this angle here will be 90 degrees. So I can say angle A is equal to 90 degrees, which is equal to angle B. So angle B dashed corresponds to this, angle A corresponds to this. Then A dashed B is common to both, so is equal to A dashed B. So I can say that the triangles B, B dashed, A dashed is congruent to A, B, A dashed. So if they are congruent, the corresponding angles are equal. So the corresponding angles will be angle I, which will be equal to angle R. So that is, the angle of incidence is equal to the angle of reflection. This is what is the laws of reflection, and these are all the waves which are traveling. These are all the waves which are traveling. I have just used Huygens principle and then I have got this. So these are all the waves which are traveling. This is all again a wave which is traveling. So thus, by using Huygens principle, we are able to show that angle I is equal to angle R. Also, we have drawn a plane triangular geometry, planar geometry. The geometry is all in one plane. So I can say the incident ray, reflected ray and the normal, they lie in the same plane. So this is an alternative definition for the laws of reflection, or alternative proof for the laws of reflection. Okay, now I'll go ahead and I'll do, maybe you can read it once or twice and then again you can try to practice it. This is a very important derivation which comes straight in the